Hi, we have come to a new topic that is on trigonometric equations. But before we start solving the equation, let's learn some basics, as in like quadrants, basic angle, so on and so forth. Now, the first thing I think you may have already known that is that the sign of the various trigonometric function in each quadrant. Now, your teacher may have told you that for the first quadrant, this is the first quadrant, everything is positive, right? So this is all. Now for second quadrant, only sine is positive. Third quadrant, only tangent, the rest are negative. And the last one, cosine is positive. So ASTC. All students take coffee. All students take Coke. Now, why is this so? Maybe, perhaps you are asked to memorize, but actually this can be easily proven. Now this is a sine graph. Now look at the sine graph. The sine graph is positive from 0 to 180. So any angles that is from 0 to 180, your sine is positive. That's why sine is positive for first and second quadrant. Now for tangent, you look at this. Now for tangent, this is 0 to 90 is positive. Alright, and 180 to 270 is positive. This is 270. Okay? Okay. 270. So 180 to 270 is in the 180 to 270 is in the third quadrant. So your tangent is positive in the third quadrant. And this is your cosine graph. Cosine graph is only positive when it is in the first and last quadrant. So it is positive for first and last quadrant. That is how we got sine. Now the next thing is you must know what is a basic angle. Basic angle is the acute angle that is made with the x-axis. Now assuming this is the angle, so this is the basic angle. Alright. Now another one, you have this as your angle. Now your angle always read from the positive x-axis. Alright. So this angle, this is the actual angle. So the basic angle is this. It's the acute angle it makes with the positive x-axis. Not positive. No, it makes with the x-axis, not necessary to be positive. Okay. So this is the basic angle. This one, alright, your basic angle is here. Alright, it's the acute angle made with the x-axis. And for the last one, alright, I will not draw the actual angle. The last one, this is the basic angle. Now, it's very important to understand the concept that is related to the basic angle. Now let's take this. Maybe I start off with sine. It's easier to show you. Now let's say this is the basic angle, theta. Alright, so this is theta. Theta is from here to here. Okay. So sine theta, what do you get? You get y. Let's see, you get y. I don't know why it's y. Sine theta, you get y. Now let's look at this graph. You also have another y here. But because this graph is symmetrical, here also will be theta. Okay, so this part will be 180 minus theta. Okay. Now what does that mean? That means sine theta is equals to sine 180 minus theta. Okay. Now let's look at it. Let's move another theta here. So this is theta, another theta. So this part will be 180 plus theta. All right, and then because it's symmetrical, so what do you get? You got the negative of this. So sine theta is equals to negative sine 180 plus theta. Now we extend this over to this side. Now this is also theta, this part. This distance here is theta because it's symmetrical. All right, it's symmetrical. I mean, these two parts is a line of symmetry here. And then this part is, you know, is actually fits exactly the same dome over here. So this is also theta. So what is this? This is 360 minus theta. All right, so we have sine theta equals to minus sine 360 minus theta. Sometimes 360 minus theta, we write this as 360 minus theta, we write it as minus theta. Okay, because it's measuring this way, all right, it's negative. Okay, maybe to save space, because I need the space later, so maybe I will just leave it as it is, and I put this can be written as minus theta. Okay, now let's look at tangent. Now all these will give you the same value, but now look at tangent. You have tangent theta. Now, what is, you move theta away from here. All right, this is theta. All right, this value here will be, if this is y, this will be minus y. All right. So tangent theta is equals to minus tangent 180 minus theta. Okay. Now move theta away from here. All right. You will find that tangent theta is equals to tangent 180. Oops, this should be a 0 here. 180 plus theta. All right. Then if you move theta to the left of 360, let's say this is theta. All right. You have the same y, so you will find that this is written as tangent theta is equals to minus tangent 360 minus theta. So this is sometimes read as minus theta if you measure the angle in clockwise direction. Okay. Now if you use the same kind of idea and you do it on a cosine graph, which I will not be doing over here, otherwise the video will be very long, you will realize that cos theta equals to minus cos 180 minus theta. All right, cos theta will be equals to minus cos 180 plus theta. Cos theta will be equals to cos 360 minus theta, and that is equals to minus theta. Okay, it's a whole bunch of things which seems quite impossible to remember. Now, but it's actually there's a way to do it. Let me just teach you. Now, one very important thing that you, from the graph, you realize that now any angles that have the same basic angle, all right, like all these have the same basic angle. If this is theta is a basic angle, then the 180 minus theta will also have the same basic angle as theta. Right, so is 180 plus theta. You look at this. This is theta. 180 plus theta is here. The basic angle is theta. All right. If 180 minus theta is this angle, 180 minus theta is this angle here. Its basic angle is also theta. All right. Now this part is 360 minus theta. So 360 minus theta is here. Then this is the basic angle. So all these angles has the same basic angle. Now when they have the same basic angle, you do a trig function to it. You realize that it has the same magnitude. That means regardless of the, we take away the sign, then the value is the same. Now what I'm trying to tell you is, you look at this. That means, let's say theta is 30. That means tangent 30 will be equals to tangent 150. Let me fill this up first. Will be equals to tangent, example 210. I haven't finished. Will be equals to tangent 330. Now numerically, just talk about the magnitude of the number. It's the same. The question is whether is it a plus or is it a minus, because they have the same basic angle. Now all angles that has the same basic angle will give you the same numerical value, not the sign. May not be, the sign may not be the same. Now if this is positive, now if this is in the first quadrant, is second quadrant, so this has to be minus. If this is, now this is in the third quadrant, so it's plus. If this is in the fourth quadrant, so it's minus. So numerically, in terms of, that means the magnitude of the number, it is the same as long as they have the same basic angle. Okay. Now, how to remember this is this. I teach you how to remember. Now, this is true for all angles. It's not necessary that theta has to be a cube. Right? This is an identity. Identity. Now, in order to remember, right, for me, I always assume, since it's true for all angles, to visualize, I will take it as theta is in the first quadrant. I take it only. Alright. Now this helped me to get the formula out. So this is in the second quadrant. So sine is positive for first and second. So you'll find that sine theta equals to 180 minus sine theta. Now take, if theta is first quadrant, this is in the third quadrant. Now third quadrant sine is negative. So sine theta is equals to minus sine 180 plus theta. Okay, I'll show you this one. How about this? Tangent theta. Alright. If theta is a cube, is it necessary that I take it as a cube? No. This is for reference only. Easier to see. If this is a cube, then this is in the fourth quadrant. Now tangent is positive in the first quadrant, but negative in the last quadrant, fourth quadrant. It's positive in the first quadrant, but negative in the fourth quadrant. So this has to be negative. All right, one of them has to be negative. All right, in order for them to be equal. Okay. Now, with this knowledge, I will now move on to the proper part of how to solve trigonometric equation, because you need all these basics. Hi. Now let me show you through examples how are you going to solve trigonometric equation. Let us begin by doing the first sum. Sine x equals to 0.8 and x is in between 0 and 360. Now this one you can just use a calculator. You key into the calculator, you will find that x is 53.1 degrees. Now, is that the only answer? No. Another answer to it is, now you look at it, if x is 0.8, let's say x is here. No, let's say this is 0.8 is here. So there's two answers. Now the other answer will be or 180 minus 53.1. Alright, so your final answer will be equals to 126.9. That means it's 53.1 or 126.9. Or it's not and, because x cannot take on two values at a go. Now you may be questioning, how do I know when to use, how do I know of this special thing, 180 minus 53.1? Do I really have to draw the graph and then to visualize? No. Now, remember we learned about basic angle. Now let's say the basic angle is theta. Okay, let's say it's theta. This is the basic angle. Now, just to recap, basic angle is the acute angle that is made with the positive, no, that is made with the x-axis. Alright, you can refer to the video earlier, alright, the earlier part of the video, alright, when I draw the basic angle for you. Now, what other angles within 0 and 360 has the same basic angle? Now, it's always the same. The others that have the same theta as the basic angle will be 180 minus theta. The other one is 180 plus theta, and followed by 360 minus theta. Now this is in the first quadrant. If theta is in the first quadrant, then this is the angle in the second quadrant, and this is the angle in the third quadrant, and this will be the angle in the fourth quadrant. Now, because these are kind of fixed, alright, well, I know that sine x is positive in the second quadrant, and given that sine x is 0.8, 0.8 is positive, so the other angle that is within 0 and 360 will be 180 minus theta. Now in general, now when you are given sine x, alright, now let's say you are given, let's say sine x is equals to k, okay, or cos x equals to k, or cos x equals to k, or tangent x equals to k. There's an x here, sorry. Then you will find that in each of them, x will have two answers. Alright? Two answers in general. Now there are special cases to watch out for. Okay? There will be two answers, regardless of whether k is positive or negative. Now you look at this graph, if k, for sine, right, if k is positive, you have two answers between 0 and 360. X must be between 0 and 360. Alright. Okay, you have two answers. If it's negative, you have two answers. Look at cosine. Positive, you have two answers. Negative, you have two answers. So it's tangent. Now, but for sine, when k is equal to 0, you have three solutions. Alright, when k is 1, you have one solution. When k is minus 1, you only have one solution. Okay, for cos, when k is minus 1, you have one solution. The rest will be 2. How about tangent? Tangent, everything is 2 except for when k is 0. Alright, so in general, alright, there will be two solutions. Another thing to take note is x. This is 1x, it's not 2x or 3x, so it's 1x. Okay, let us do another example so that you will understand it better. Now let's do question 2. Now question 2, you are given tangent x is equals to minus 2.5 and x is between 0 to 360. All right. Now, because we want to make use of this, all right, so it is easier if we ignore the minus 2.5. Reason being, we want to find the basic angle. After that, we just apply what we know about here. Okay. Now, the basic angle will be 2. So x will be tangent inverse 2.5. This will be the basic angle. And then you get the answer of 68.1. Okay. Now, all basic angle, when you do a trig function, let's say I do a sine to each of them, you will say you have the same answer. I'm not talking about the sine, the same answer, the numerical value, just the magnitude of it is the same. All right. When you do a cosine of each of these, you will find that same thing you do tangent. All right, you will have the same numerical value, but the sign may be different. Okay. Now, so this is the basic angle, all right? So it's just for working purposes. But you know that tangent x is negative, so x cannot be this. So what are the values of x? X must be in the second and fourth quadrant. Because tangent x is positive in the first and third quadrant. So when this is negative, x has to be in the third. It has to be in the second and fourth quadrant. So my answer for x will be x is 180 minus 68.1 or 360 minus 68.1, and that gives you 111.9 or 291.1. Question number 3. In question number 3, you are given 5 sine x plus 3 cos x is equals to 2 sine x minus 7 cos x. Now x is between 0 and 360. So you are asked to find the value of x. Now let's group the like terms together. So you bring this the cos x over. So you have 10 cos x. And bring this over, you have minus 3 sine x. Now you can divide by cos x on both sides. So you have 10 equals to minus 3 tangent x. Now, so tangent x will be equals to 10 over negative 10 over 3. Now, if you press a calculator, you press tangent inverse 10 over 3 to find the basic angle first. Alright, so you will have 73.3. Now, this is the basic angle. It is not the answer to it. This is just a reference angle. This is for working only. Now, you look at this, tangent x is negative. That means it is in the it is in the second and fourth quadrant. Now, if it's in the second quadrant, so x will be equals to 180 minus 73.3, right? Or 360 minus 73.3 degrees. What will you get over here? You get 106.7 degrees, and this one you have 286.7 degrees. Now these two are your final answer to question number 3. Now in question number 4, you're given this equation and you are asked to solve it. So you have 4 sine square x plus 5 sine x cos x minus 6 cos square x equals to 0. And x is between 0 to 360. Now, if you divide this equation by cos x on both sides, you will find that this will change to tangent square. This will change to this cos square divided by cos square will be 1. Here, you sine x over cos square x. The cos x and the cos square can cancel, and then you are left with tangent x. So it becomes one unknown. Okay, so let's divide by cos square x. So you will have 4 tangent square x plus 5. Now divide by cos square x and cos x cancel, so sine x over cos x, you are left with tangent x minus 6 equals to 0. Now you look at this is just a quadratic equation. Okay, you can use a quadratic formula, or you can complete the square, or you can factorize if it's possible. No, this is possible to factorize. So you got 4 tangent x minus 3, 2, oh sorry, this is 1. So you have tangent x plus 2 equals to 0. Okay, so to solve this, you will have tangent x equals to 3 over 4 or minus 2. Now let's solve this first. Now, so this one, you just simply press a calculator. So x will be 36.9 if you press a calculator. Now, this is positive. So there's also another angle which is in the third quadrant, because tangent is positive in the third quadrant. And that will be 180 plus this. Alright, because 36.9 is also the basic angle. So that will give you 216.9. Now, for this, x is equals to, now when you press a calculator, you press tangent inverse 2, alright, because you want to find the basic angle. Basic angle. So this answer will be 63.4 degrees, alright. But this is just the basic angle. But you know that tangent is negative. So when tangent is negative, it is in which quadrant? It is in the second and fourth quadrant. So for second quadrant, the angle to have this basic angle will be 180 minus this. Okay. Now 180 minus this angle, what will you get? So you got x, it is equals to 116.6. And another angle will be 360 minus this. So you will get, I think this one I changed to an or. It's not, this should be an or. Alright, or 360 minus 63.4, and then I get 296.6 degrees. Okay, so you have 4 solutions. Alright, so your final solution will be x is equals to the 6.9, 216.9, 116.6 and 296.6. So there are 4 angles that for x, if x is between 0 to 360. Now this is one of the method. Now the other method is, if you look at it closely, you can actually factorize this. Okay, so maybe I would just put it up here. Method 2. Now, if you look at it properly, this can be factorized into 4 sine x minus 3 cos x into sine x plus 2 cos x, okay, equals to 0. That means this is equal to 0 or this is equal to 0. Okay, so you have 4 sine x minus 3 cos x equals to 0, or sine x plus 2 cos x equals to 0. Then from here you bring over and divide, you got tangent x is equals to 3 over 4, or tangent x is equals to minus 2. You find that these two is the same. So you can just repeat this procedure to find the answer. Honestly, which method do I prefer? Now, if this question can be factorized, of course, this is a bit faster. You don't need to divide by cos squared. Only slightly faster. But if this question cannot be factorized, then it's a bit hard to see if you don't factorize it. I'm not saying that you need to, all right, but it's a bit hard to see if you cannot factorize, all right, if the expression can't be factorized. Now, then in that case, this would be better, all right. So if you can't factorize, you can just divide by cos squared, all right. Like in this case, let's say if you can't factorize, divide by cos squared, then you get the expression like that. Then you can use the quadratic formula, or you can solve it by completing the square. Okay. Now for that, we have come to the end of this video. If you like our video, please press the subscribe button. Thank you very much, and thank you for your support.